time. It is time. Hey there, everybody. Welcome again to Astronomy Daily Live. This is a daily live stream using Google Hangouts where, a bunch of us get together pretty much each and every day and just talk astronomical things and spacey things and science in general. Sometimes we can get a little bit philosophical. Bobby, there's two of you. There are two of you on the panel. That's great. Which one do I talk to?
The one that's got the webcam.
Okay. So Bobby,
yeah, my Chromebook froze.
Oh, okay.
I want to see if Google's got some support, and maybe they'll fix that freezing issue.
Okay. Yeah. Well, you're about the only one, so now I know which one to talk to. So no problem at all. So welcome again to Tom on the panel. Hey.
Hey, Cosmic.
Hope all is well with everyone out there. Everything is good here. Just a normal day. Supposed to be getting some precipitation. I was sort of expecting it to already be here, but it's just taking its time. So I think inevitable. I don't know how cold it's going to get though. It's actually not very cold. We can actually go over to the chat here. I've got a Nightbot, and we can ask it a weather question.
Well, my weather bug app says it's -4°C here, so it's pretty cold.
Ooh. Oh, ouch. Yeah, see here it says it's 50 degrees Fahrenheit, 10°C. So
that's not bad.
Yeah. I think it's a little surprising that it's that warm, but that's that's how it is. So I think it's supposed to get a little bit colder. But so other than that, yeah, everything's good. I always try to start preparing for this live stream about quarter till, and for several months I actually had my smartphone on and set to a daily alarm at the appropriate time, and it's kind of interesting because over the course of a few months or so I've really tuned in to that time. So I usually have a pretty good idea during the course of the day, like how much longer I've got, and I sort of keep track of this now. But today I was a little bit distracted because I was looking at the image data that I took the other night through my telescope back here, trying to do some photometry of stars that are 11th magnitude and brighter, and so the other night I was sort of contending with two things. One, I was contending with the dew point, which isn't rare here. What's kind of rare is how early in the evening I was actually reaching the dew point. I mean, things started getting wet here like around 8 o'clock local time, which is super early. We usually don't reach a dew point until like 1 or 2 in the morning. So I figured I had a couple hours at least, but I didn't. And the other thing I was contending with, which is something that I knew that I was going to contend with was the pointing of this telescope isn't really great. It's if nothing, it's sort of inconsistent. So sometimes it's really good, and sometimes it's really bad. Um, and most of the time, somewhere in the middle, right? Um, rarely is it really good. Well, the other night it was actually pointing really well. I mean, I've got a really narrow field of view, and it was putting target stars in that field of view, but the target stars I was testing were visible, right? So I was looking at Vega, I was looking at Altair, I was looking at Capella, I was looking at Mars, but the telescope was really pointing well, right? So it's like, okay, I'm going to go after a target that I can't see, right? I've got to rely on what I see in the field of view and charts to show me where in the sky I'm actually pointing, and then star hop back to my target, right? So yeah, I did this, and to try as I might, I did not see a pattern that night. And like I said, I think I would have given it much more time, but I was contending with actual like dripping wet things, and most of those kinds of things don't like to be dripping wet. They don't work really well. so yeah, I had to cut it a little bit short, but I did collect a few images, and I was looking at them. Well, right in the middle of last night's stream, I actually saw the pattern I was looking for. So this morning and today, I was looking at it again, and yeah, I'm pretty sure. I'm not 100% convinced, but I'm 99% sure that the pattern that I'm seeing on the chart matches what I'm seeing on the sky. And I'm just going to quickly share that screen again, just to more than anything else, just for the record. All right. So here on the left is an image from my scope and CCD camera, and you can see right way on the edge here is a star, and then there's a bright star, and then there's this faint guy down here and a brighter one here, and maybe something here, kind of hard to tell, right? But this pattern, right, with these two stars, you can sort of draw a line, and this line intersects this line about halfway, right? So I mean, it's a pretty recognizable pattern, especially if you've got a bright one here and a fainter one here, right? That's a pretty recognizable pattern. But I've got a few of these. So there's another one. So here's one where that faint one and the brighter one. So here, if I go back, so faint one, bright one, right? I go to the next one. Here's the faint and the bright. There's 1, 2. Well, here you can see 1, 2, 3. 3 stars in sort of a weird pattern here. Maybe something else here. So, and there's almost the same field. Here's that bright and fainter again with that upper bright one, and there's another one up here. So So now if I take you to the chart, and you sort of have to translate this in your head a little bit, right? What I'm seeing is bright is this guy. And then this little guy is here. This faint guy is this guy. And then this one is that one right there. So that makes a triangle. Here's a triangle. And the field of view matches too, right? Here's my field of view. So you sort of have to rotate this around, right? But from here to here is about the same width as that, and that's exactly what we're seeing here. Right, so the field of view is correct, and that pattern is correct. Right, so if we go to oh, it's this one. So if we go to this one, right, we've got faint, bright, and then these three here, or these three here. So yeah, I'm pretty convinced. Now, the frustrating thing to realize here, right? How, this is this bright, right, this guy. This guy. Well, here, this guy. Okay, this is what the telescope pretty much pointed to every time I tried to go to, a designated right dimension and declination. I always saw two stars. Look how close I was to my target. This is my target star. This is my target star. Look how close I was. So if I would have seen, right, I would have been like, okay, I just have to move over a little tiny bit right there. I would have seen it, right? It would have been way off, right? You sort of follow this. See how this sort of wraps around. So it's going to wrap around. It's going to be way off screen here. So yeah, that's sort of the frustrating part. I was so darn close. But that pattern until 24 hours later, and that's just not, I've got to be able to do this much less than 24 hours. So I think it's just practice. Now I sort of know what the scale is, what the magnitude look like, when I know what magnitude those stars are. So yeah, I think it'll actually be now, because I sort of know what field of view I'm dealing with, and so I think it'll be easier. I think it can only get easier. So yeah, to get that down to about 30 seconds.
Yeah, you just need to go out and do it, right?
That's it. Well, now it's just the astronomer's dilemma. It's those.
Now that you did yourself a better job, are you going to try to improve it?
Yeah. What the preliminary work that did definitely pointed in the direction of this being a really, really nice system. Now, what I have to do is sort of this task and sort of filling in some of the gaps, because I have a preliminary look, but really, I mean, I'm basing my confidence on a handful of bright stars, right? Maybe a dozen, maybe, right? So I would like to, triple that, right? I have a large sample of 11th magnitude and brighter, and see if measurements of those are consistent with my current measurements. and I expect that they're going to be. But yeah, to be able to fill in that gap, because I'm like I said, they're sort of two really, really nice selling points about here, uh, and is the dark sky, right? The dark sky that, and we also clear sky. So that's a big selling point because not very many have that. The second is that the quality of the data is very, very good. I mean, it's at least adequate to be able to do science if you're into that kind of thing. So those are two really nice selling points, and so yeah, I think sort of I'm full steam ahead. I just need to fill in these gaps because then that'll give me the confidence. I'm really, really rough on most of these kinds of things. I mean, they have to be right, and I have to be absolutely convinced. Right? Otherwise, I can't. I want to do so. I have to make sure it's going to work, or there's no point in doing it. So, yeah. But I think this is. I think those are two very, very good selling. So I think there are going to be some interested parties in this kind of stuff. It's just going to be on me to be able to deliver the quality of the data. So sort of a different kind of thing. There are these automated observatories, and but I keep the answers in terms of data quality. So yeah, I don't know, and that's sort of my first question, right? Is that if you're going to be offering scientific quality data, well, how good is it? How you measure that? So, and I don't know if anything anybody has really looked at. I think it's really the most important thing. So, it's the garbage in and garbage out theory. I mean, if data is really, really bad or not calibrated or who knows what, your results aren't going to be what they should be. And you're either going to be frustrated by the results or you're going to misinterpret the results. And so, yeah, the quality of the data has to be really high. And I haven't been able to get any kind of answers from most of the automated systems. So probably have to somehow get a hold of some of their data and run it through my own thing to see how it compares. Could be better. I have no idea. So yeah, that kind of be an interesting thing to do. All right, well, cool.
At least you still have fun.
Well, as long as I'm having fun, it's exactly all that matters. Absolutely. And yeah, this is a bunch of fun.
On the on the topic of the night sky, if any of you are interested in Neptune, this is a good time to see it. Neptune and Mars will be in close conjunction for, I guess, the next couple of nights. If you can find Mars in the south sky, you should be able to see Neptune. It's a little bit above and to the left. You'll probably need some binoculars to see it. It's magnitude, what did they say, 7.9 in early December.
Actually that's as bright as it gets. Right? So Yeah, you should definitely be able to see that in just some basic notes. Yeah, for sure. I think it's sort of blue, right? It's sort of color.
Yeah, yeah. Neptune's blue. I think it gets kind of washed out when it's that small and far away, but it should look a little bit blue tinge.
Yeah, yeah. Some of these things you sort of have to use your imagination a little bit. Like, yeah,
Absolutely.
blue, like blue, definitely blue. Yeah, the comet, uh, Wirtanen, uh, does does look a little sort of greenish bluish. Yeah, for sure. I mean, definitely some color. Definitely not gray thing. It's got a tinge or something. So yeah, but you have your imagination a little bit with that. Color in just a little bit. No harm. All right. Well, great. Let's see. That I posted some papers over on the Discord, and
Um, and Uncle Bill loading Stellarium. I think we looked at NTC 5701 yesterday, and maybe Uncle Bill could take a look at that.
I think it was 571.
It's either 5701 or 5071. I forgot. You forgot
I don't
too.
remember.
What the deuce?
I remember either. Yeah, they're both spectacular.
Well, I think we ended up looking at both of them a little bit.
I think they did. Yeah, I thought that was an interesting coincidence. That paper had listed that one. I don't know. Maybe. Well, yeah. I was going to say, maybe that was a typo in the paper. Actually, was 071. Maybe. I don't know. I didn't look that hard. I don't know. That'll be a mystery. Be a mystery. Like mystery. So yeah, I sort of thought. Audio is confused. Sorry. 5071. 071. But we looked at 5701, right? Was that the one? Or five? I don't remember what it was now. 5710? I think it might have been 5170.
Or 5701. He's looking for Neptune at the moment.
Oh, okay. Maybe 5701. Looking for Neptune. Sounds like a book. Looking for Neptune. Yeah, if you haven't seen all the planets and you have, binoculars is okay to sort of see the light from Neptune, but in order to actually see, the planet itself, actual disk, you definitely need a telescope, right? And a little bit of magnification. You don't need a huge amount. Excuse me. But it's extraordinary to actually see, a round disk, right? I mean, it's not a point source. It's extended, round, basically blue circle. And I can't remember. Can't remember if Bobby, you're breaking up. You're emphasizing. He turned into a robot. Now he's frozen. Oh, I think he's gonna vanish. Yeah, I think so. going to lose Bobby very, very soon. Yeah, I'm sort of thinking that maybe also through a telescope, maybe you can see some limb darkening. Oh, I don't remember exactly. It's been a while, but yeah, definitely if you ever get a chance to see any planet, right? The popular Jupiter, Saturn, Mars. Those are the ones those, sort of see time. So Uranus and Neptune are pretty amazing, right? And out there, pretty big, so-called gas giants, and yeah, and Neptune definitely has blue hue. Uranus has sort of a greenish color to it. So yeah, and actually see an actual. Then of course realize the light path, right? So the light that you're seeing, it started from the sun, went all the way out to Neptune, and then reflected off of Neptune, came towards you, hit your eyes.
I'm trying to get a stellarium, but I think it's one.
Yeah, you are not audible. I didn't really get much of that at all.
Nope. Bobby was cutting out a little bit there.
Bobby, your technology is failing you once again, just like it fails us all.
Yeah, I haven't seen Neptune or Uranus except in pictures so far, so I may have to get out and try and catch it tonight or tomorrow.
Yeah, absolutely. Absolutely. Like I said, seeing it is a special form of touching, because I mean, what you're actually doing
Yeah,
is
I'm trying to.
goes on. Oh, you're just feeling a disturbance, this electromagnetic field, and in a certain sense, you're sort of and you really get that. Look at a picture of it. It's absolutely not the same thing at all.
It's a different view of those photons, yeah.
Yep. Yeah. So definitely get to take a look at that. Look at Pluto too. Pluto's pretty cool. It's that just looked like, so that, yeah, that's really, really small and really, really far away. So it's I think in most scopes, you're not going to get much more than just basically, it like a star. But Uranus and Neptune, oh yeah, absolutely. You can also see some moons of Uranus, and Neptune. Doesn't Neptune have the moon Triton? Isn't that right?
That sounds right.
Yeah. Okay. And I think you can see Triton.
Cosmo, can you hear me now?
I can at the moment.
Yeah, I was trying to get a stellarium, but it's a little bit super sluggish for it.
You got one of those potatoes.
Yeah.
That's a great term. I like it. That is definitely an Uncle Bill term. A potato. Yeah. Pretty funny. So yeah, all right. Well, like I said, I posted a couple things over onto the Discord. A couple of papers that sort of looked a little interesting. The one that sort of caught my eye a little bit more than all the others. Let's see. Let me get myself over there. Do-do-do-do. Uncle Grinch is typing. It says on the Discord right now, it says Uncle Grinch. So we have a new persona who has taken over one of our regulars and is now Uncle Grinch. All right. I gotcha. Are you that way over?
I think Uncle Bill's been working too much lately, and it's starting to get him down a little.
Well, if that's getting Uncle Bill down, then I sure like to keep him down. That's great. Okay, let's see. I was going to go over to Discord. Uncle Grinch. That's funny. And then I will share my screen. Hide that. Go to infinity. By the way, if you haven't seen this yet, this, definitely take a look. This guy, he's a mathematician, but he does all kinds of interesting things, and this is one of his more creative things, and I think it's just take a look at it. Yeah, it's but it's called Infinite DVD Unboxing. So sort of imagine what that might be, and then take a look at that if you haven't already.
I watched it last night. It was interesting.
Yeah, that was pretty darn cool as well.
I thought so. I'm of course, I immediately try to figure out, how he did it, and that's no fun. So I may think about it a little bit more, but I just really like it. I think he did they did just a great job at that one. So yeah, pretty good. But yeah, he tortures himself. He computes, like 100 decimals of pi, and just does all kinds of wild mathematical things. And but yeah, this was pretty good, gotta say. So let's see. So this is something that I guess I never really thought about, and that is the definition of the galactic plane and how that's defined. Because it has to be, and to a certain extent, I think they can define an actual three-dimensional plane, right? Not just sort of a line that goes across our sky, but an actual three-dimensional plane. I'm not quite sure, I don't know if they get into this or anything in the paper, but I'm not quite sure what all those angles would sort of be relative to, but I think what they're showing here is just a sort of a correction to what we currently have. Now, I don't think that this is like being adopted or anything. I think it's just maybe a suggestion. I'm not exactly sure, but I just sort of kind of thought it was neat because I'd never thought about this before. How does one define the galactic plane? Because for people who are really interested in studying galaxies, knowing very, very accurately and very confidently where the plane of the galaxy is makes a difference in terms of how you view relationships between things and how stuff moves, and there's all kinds of interesting um, relationships there based on sort of this really, really, really basic thing. And so it was kind of neat to see a modern paper trying to define that. Maybe make an improvement. I mean, I don't know how you would measure an improvement, but so yeah, they're taking the distribution of these regions of the galaxy that are called H2 regions. They're regions of like star formation. They're big, relatively warm and or hot clouds of gas and dust. And I guess according to this distribution, these folks are defining the galactic plane. So let's see. I don't know if I want to get into this too much, but let's see. So we develop a framework for a new definition of the galactic midplane, allowing for tilt and roll of the midplane with respect to the current definition. Okay, so they're taking what it currently is and I guess adding a tilt and a roll. Okay. Derivation of the tilt and roll angles also determines, the solar height above the midplane. Yeah. So yeah, H2 regions, analyze various subsamples, and find that all have galactic latitude scale heights near 0.3 degrees. I'm not quite sure what that means. The Z distribution scale height near 30 parsecs. Let's see. Distribution. Larger regions have migrated further from their birth sites for all H2 region subsamples and for a variety of fitting methodologies. We find that the HMSF midplane, HMSF high mass star formation midplane, is not significantly tilted or rolled with respect to a currently defined midplane. Okay. Okay, so I guess they defined it back in 1958. So it comes from the galactic center, which is shown there, and the North Galactic Pole location, which is there. Okay, cool. Let's see, some previous studies of the vertical distribution of objects and solar height above the plane can be categorized using stellar or gas samples. Previous results. Let's see, okay, yeah, I'm just not totally following this, but sort of looking at the numbers and being like, huh, well, moderately consistent. These are way out there. Peak, whatever. I'm not quite sure what that is. That's well, that's sort of consistent. It's hard to tell. Hard to tell. Okay. Let's see, so Saturn star is the so-called center of the galaxy. That's the object that is seen there, or at least that's as close as we can see to anything. So let's see. I'm not quite sure. Azimuth. Okay, so this is sort of looking down at it then, right? Azimuth going around like that. Yeah, face-on geometry of the two coordinate system used here as viewed from the galactic North Pole. Angles are exaggerated for clarity. Thank you. Unprimed coordinates are centered on the Sun. Prime on Sagittarius star. Okay, I got you. So X and Z and okay. Huh. I wonder why it's flipped like that. Don't know. Let's see. We developed methodology required to define the midplane using a sample of discrete galactic objects. We need to use two coordinate systems. Sun-centered and Sagittarius star-centered. Huh, I wonder... They just sort of say that they need to do that. I'm not quite sure why. Yeah, we probably dive into this a little bit more to really get it. So I'm not going to try hard. These are just rotation matrices, just linear algebra. Really not so hard. Not really so hard. So, let's see. Okay, here we go. So here's the, I guess, the current midplane, and here's the modified one. So, yeah, not quite sure what's going on there. Would really have to dive into the paper. As with most of these papers, they're complicated. Right? Some complicated math here. Linear algebra is pretty complicated. Some things are easier than others.
Hey, check the chat.
Check the chat. Check the chat. Let's see. All right. Well, very cool, Mr. Small's Salt and Vinegar. Nice to see you in chat. We're just doing astronomy here. We're looking at a new definition of the galactic plane. So, yeah, you know, without getting into this incredibly intensely, looks like, let's see. Yeah.
Hey, you better check the chat again.
Oh, checking the chat again. Cool. All right. Well, we will see. In the meantime, welcome that kid named Matt. Nice to see you in the chat. Excellent for you to be here. We're looking at a new definition of the galactic plane. So, yeah. Probably have to really dive into this to totally understand it. These are busy little plots here. So, not quite sure. Let's see. Geometry used for calculations of the mid-plane tilt rotation angle, height above plane. Angles exaggerated 30, and are indicated with green lines and font. Okay. Okay, so this is supposed to be like an H2 region. Okay, I gotcha. And that's what this is too. Let's see. So prime quantities correspond to distances.
All right. Get the chat again.
Are we getting exciting over there?
It's either we got trolls or we got idiots.
All right, and look at that. Nightbot is just wiping them out. Hey there, the human. Nice to see you again. Cool. Let's yeah, we're just gonna take care of these guys. Let's see. Just taking care of a few of these guys. That's great. That is, it's very, very cool that this is happening, and I'm also pretty impressed by Nightbot. Nightbot just like did this serious slash and burn. So that was pretty nice. I like it. Okay. So yeah,
I think that was a good Nightbot.
I think that was a great Nightbot. So okay. I mean, you know, like I said, and I'm going to continue to say this for probably quite a while, right? I mean, this is definitely not any kind of problem at this point. This channel is too small, and so, but yeah, you know, if Nightbot can handle those kinds of things, far out. We just have to make sure that Nightbot keeps you know, isn't rude, because we don't want rude. Let's see. Okay, so the modified midplane is tilted by an angle theta tilt. Okay, so yeah, I guess this is the actual plane that they're talking about. I want to know what that angle is, though. Right? That's what we really want to know. Yeah. See, there's a tilt and there's a roll. So what are those numbers? That's what we need to find out here. What numbers did they come up with? I mean, they have to tell us, right? Let's see. Midplane tilt. Let's see. Did they give us a... Okay, so... I'm thinking that these are probably it based on, I don't know, you know, different parameters. Not quite sure. So, oh, here's the tilt. Okay, so in degrees, right? 0.01 degrees, 0.07 degrees, and then a roll. Oh, these aren't the same. Oh, yeah. Again, you know, without getting into the paper, I'm not going to be able to really properly interpret these. But, you know, these are, I mean, I would say that that's pretty significant, right? That's a pretty significant angle. I mean, these are in degrees. I'd like to see, well, I guess they, you know, if this is as good as they can get, you know, plus or minus 0.01, then maybe they can't really allow for any more decimal points. But 0.01 degrees is 36 arc seconds. And that's, I think that seems like a lot. And that's sort of the smallest one, right? I mean, there's 0.07, right? What's that? 0.07? 0.07, whoop, 0.07 times 3600 is, wow, 252 arc seconds. That's 4.2 arc minutes. That's like a little, what, like an eighth the size of the full moon? Is that right? I think so. Yeah. So yeah, that's a pretty big angle. So wow, yeah, that seems pretty big. I guess I was expecting a lot less. But wow, okay. But it's kind of hard to tell, because their error bars are pretty big compared to the values, right? So, but pretty interesting. And again, I just sort of thought it was kind of neat, that people are thinking about this, because I think it does make a difference, for sure. I don't know how big of a difference, but kind of neat. Let's see. We studied the framework. I always like to look at the conclusions, because that's where you can sort of get a lot of interesting things. So they're saying that the midplane that they found is not significantly different from the current one. I don't know. That seems like a lot. Maybe it's not, though. I don't know. Negatively correlated. Okay, so our values are, however, broadly consistent with the results of others. Long bar is B is approximately negative 0.1 degree. Bar lies plane after accounting for the midplane tilt. Okay. These results and applicability of our methodology using various permutations of our sample. Yeah, and I guess that's what these other things are various permutations. Yeah, there isn't a description of this table here or anything. So, but pretty cool that they're thinking about those kinds of things. And yeah, like I said, in terms of galactic dynamics and all of that, probably makes a difference where those things are. And how they're being interpreted. So pretty cool. Pretty cool. Well, I'm looking at the time, and it's a little early, but I'm sort of thinking that maybe it's time to get on out of here for today. Yeah, I think so. So let's do it. Let's get on out of here. So thanks everybody for coming in. This is a lot of fun, and it's great to sort of just share this with you all, and hopefully it's a little bit fun for you as well. And yeah, let's do this again sometime really soon. Like, well, I'll be here in a little less than 23 hours. So maybe I'll see you then. I hope so. All right. Well, take care, everybody. Have a great evening, a great day tomorrow. Make sure to subscribe if you haven't. Thumbs down, thumbs up, whichever you prefer. Make some comments. Spread this around, right? We're trying to find sort of a nice core group. So far, I think what we've got is absolutely fantastic. But I think it shouldn't be too hard to find a live stream group at least in the 20s or 30s. That's my guess. Now I'm still singles. Sometimes I get up into the teens, but yeah, I'm thinking that, I mean, worldwide, I think that there is definitely a group of 20 or 30 of us, you know, that is going to be consistent. So, and I think that would be absolutely fantastic. That'd be a really, really interesting and dynamic conversation, and you know, much more so than now, of course. So, yeah, I think they're out there. Spread the word. And you know, my thing is to be here, be consistent, and be moderately interesting and entertaining, I guess. But my whole thing is I'm just showing the passion. I'm crazy about astronomy, crazy about the universe. It you know, completely amazes me. So I'm just in absolute awe, and you know, to have some sort of rudimentary tools to sort of, you know, examine this universe we're in, it's kind of a neat thing. You know, we don't necessarily just have to sit back and wonder about it. We can dive in a little bit more and at least gain maybe certain levels of understanding. So I think that is very, very satisfying. So I'm going to keep doing it. And like I said, you know, I've been doing this for years and years and years. So the only difference between what I have been doing and what I'm doing now is that I'm talking out loud. So, and that's extremely easy to do. So, all right, you guys, I'm going to get out of here for now. Take care. Thanks for coming in. And in a little less than one spin, I'll be back. All right. Take care. Bye, everybody.
Later.